Hello and welcome to another one of these ADD videos. Today we're going to be looking at this example of a redox reaction. If you remember the rules of a redox reaction, we're supposed to assign the oxidation numbers to each one of these guys first. Then after that, determine which one's undergoing oxidation, because in oxidation, lose electrons, therefore you become more positive. And in reduction, you gain electrons and you become more negative. So let's see it in action. Let's start out with this potassium chloride here. If you look at the rules for oxidation numbers, potassium is an alkali metal, so you give it a +1 first, and then a -1 has to be there for chlorine to give that a neutral zero charge. Then you look at this here, we got manganese oxide, dioxide, sorry, because it is a metal, non-metal. And the only one that's on the list for reliability of oxidation numbers is oxygen, and there are two of them, so you get a -4, and therefore manganese must be a +4 to counteract that. Alright, so we got K2SO4 here. K2 and H2SO4 are pretty much going to be the same thing. They're both going to employ the +1 charge. And then whenever we come over here to the sulfate, they're going to give you a net -2. So that's what goes up here. And then at that point, we can figure out what the sulfur charge is. And it's going to be a +6 if you solve this equation, because you're going to have a -8 plus something equals a -2. So you add the 8 and you figure out it's +6. I'm going kind of fast. This is the intermediate video. You should already have most of these concepts down by now, especially assigning oxidation numbers, since there is a set of videos dedicated solely to that. So again, between here and here, we know sulfate will be -2, and we have the +6 again for the sulfur. As a result, this will have to be a +2 to balance that out. So there's that calculation. For the water, we're going to have a +1 for the hydrogen, which is what it was in the H2SO4 by the same analogy, right? Hopefully you guys get that H2SO4 and K2SO4 are going to behave pretty much the same, because both the H and the K plus take precedence on their reliabilities, and they're both going to be a +1 charge for their oxidation number. The H did not change, neither did the oxygen. It was still a -2. So what did change is the question. Well, let's look first at the manganese. Prior to the reaction in this dioxide, it was a +4. But then here it became a +2. So therefore, in the reactant sides it was a +4, in the product side a +2. Less positive means it gained electrons, right? So therefore it's undergoing reduction, and this would be the half reaction that you would see with the oxidizing agent being here. Remember, the oxidizing agent undergoes reduction. It picks up the electrons that's given up during the process of oxidation, where oxidation is actually the loss of electrons. So that's why it's counter the process, even though its process of oxidation is losing electrons, the oxidizing agent picks up the electrons. That's why a lot of people use the double agent metaphor to think of the oxidizing and reducing agents. So now let's look at chlorine. Oh, I didn't do the chloride by itself up here. Remember, chlorine, because it's the chloride is diatomically bonded to itself, there is going to be a 0 charge. It's a molecule. There's nothing else to compare it to. Okay? All those that are bonded to themselves are going to be 0. So it was -1, then 0, so it became more positive, therefore it lost an electron, and chlorine undergoes oxidation, and there would be a half reaction. The chlorine on the reactant side is the reducing agent, so therefore it gives up the electrons that allows for reduction to take place. Okay, so the reducing agent actually undergoes oxidation. It gives up the electrons. Alright, so hopefully that has clarified things for you. I know at first it was a little intimidating, but after you look at it for a while, do a few of these problems, you should be able to get the hang of this. You need to be able to be well versed in this process in order to handle the ion electron method. So practice, practice, practice. Thank you and have a nice day.